Have you ever wondered why it's harder to stop a speeding truck than a bicycle? The answer lies in a fundamental concept in physics known as momentum. Picture an object in motion. This object carries with it a certain oomph that keeps it moving. This oomph is what scientists call momentum. It's a vector quantity, meaning it has both a magnitude and a direction. To understand momentum, think of it as a product of mass and velocity. Simply put, it's the mass of an object multiplied by its speed in a specific direction. So, a heavier object moving at a fast speed has greater momentum than a lighter object moving at the same speed. Consider a rolling ball. If the ball is large and moving fast, it has a high momentum. It's harder to stop because of the amount of oomph or momentum it possesses. The same principle applies to the speeding truck compared to the bicycle. The truck, being heavier and moving faster, has more momentum, making it harder to stop. But what happens when an object's velocity changes? Its momentum changes too. This brings us to the concept of impulse, which is the change in momentum. When you apply a force to an object for a certain amount of time, you give it an impulse and its momentum changes. Let's take the example of a soccer ball. When a player kicks the ball, they apply a force over a short period of time, changing the ball's momentum and sending it flying towards the goal. Now, what about when two objects collide? This is where the principle of conservation of momentum comes in. In a closed system, the total momentum before and after a collision remains constant. This is why, when two billiard balls hit each other, one ball stops while the other moves away with the speed of the first. The total momentum is conserved. To sum up, momentum is a measure of the oomph that an object in motion possesses. It depends on the object's mass and velocity, and it always has a direction. A change in momentum, or impulse, occurs when a force acts on an object for a period of time. And in a closed system, momentum is always conserved during collisions. So next time you find it hard to stop a speeding bicycle or watch a soccer player make a powerful kick, you'll know that it all comes down to the fascinating concept of momentum. It's not just about the mass or speed of an object, but the product of the two. And remember, it's the oomph that makes the difference.